So TechLog 3 is a software that we'll use to control multiple fans, and we'll do a demonstration of the setup and operation using TechLog 3. So in this TechLog 3 demonstration, we're going to show a fully guarded multi-point test on a 3-unit townhome. So we have a fan set up in each unit, and all 3 fans will be running simultaneously to do a multi-point test. TechLog 3 will show you the results of that fully guarded test, but what we're going to show is how to, from that information that TechLog has gathered, get a multi-point test for each individual unit. So for Unit 1, what are the multi-point test results? For Unit 2, what are the multi-point test results? And for Unit 3, what are the multi-point test results? In previous demonstrations and webinars of using TechLog, we've covered a lot of other ways, but this way hasn't been covered yet. So we're going to focus on that in this demonstration. So the first step is we've got all the equipment set up, we've got the gauges set up, cables run, we're running Cat5 cables back to the computer, and all the tubing's connected, and now we're going to gather the information that we need to enter into TechLog to do the test. And in TechLog, in the help menu, you can print off this configuration worksheet. So we'll draw a sketch of the building and where the fans and gauges are, and then we'll gather the information about the serial number from each gauge, and we'll give each gauge a label, and so you can come up with your own protocol on how you want to label the gauge so you understand which gauge that is. And then we'll also label what we're using channel A for, and we might be using that for an envelope pressure. There's 3 different types of pressures you can choose. Envelope pressure is your building to outside pressure. An interior pressure, if you're doing a test where you want to monitor interior pressures to make sure they're within, say, 10% of the induced pressure, then you can monitor those interior pressures and have them show up on a report where it's comparing that interior pressure with the envelope pressure, or you can label it just a generic pressure. So you can label either channel A or B as one of those 3 types of pressures, or you could label either channel A or B whether it's going to be a fan flow, whether it's a duct blaster fan or a blower door fan. So let's look at that information. So this is how we have it set up. Unit 1, 2, and 3 here, and we've got 3 fans set up, and with the configuration of the gauges is going to be what we typically see with a single fan test, because this is like doing 3 single fan tests on 3 units at the same time. So channel A is going to be an envelope pressure, channel B is going to be a fan flow for each of those 3 units, and you can see I've got the serial numbers documented there. So let's launch TechLog, and we'll start doing that demo. So I'm going to just launch TechLog 3, and we'll get that configured for this test. So the first step is we'll go up to Configuration, Settings, and we'll scan for ports and devices. And in this case, we've used a serial to Cat5 adapter. So on each gauge, we've got a serial to Cat5 adapter, and then we've run the cable back to our computer, and we've got an 8-port serial to USB hub. So we're connecting each of those 3 gauges to this hub, and then that has a single USB cable that goes to the computer. So we're gathering all that data from the 3 gauges over that hub. So now it's located all 3 of our communications, and you can see it's scanned for Wi-Fi link, so you can use any combination of wired and wireless devices. for this test. So so now in serial number here, I'm going to double click, and we've got in unit A we've got gauge 20631. So we'll choose 20631 and we'll label that unit 1, so we know which unit that gauge is in, and we'll click on that box, double click in the serial number, and for unit 2 we had serial number 19344, call that unit 2. And then we'll go down to the last one, call that unit 3. Okay, and then I'm going to click on View and Edit Channel Settings here. Click on that, and now you can see the 3 gauges are labeled across top on 3 tabs. So the first one, channel A, is an envelope pressure, and we'll call that envelope 1. And then channel B is a duct blaster fan flow, so we'll call that fan 1. Some pretty original labeling configurations I've got here. So we've got another envelope pressure, envelope 2, another duct blaster fan, fan 2, and then clicking on the last gauge here, we've got three gauges here in the last one. Another envelope pressure, envelope 3, and 3. And I'm going to click OK here, and we've got our gauges configured. OK there, and now we're ready to start recording. Start recording. So initially it did a search to see what gauges were out there, and now it's going through the process of making the handshake with each of those and starting to enable the communication and start gathering data. Once it's done with that, it'll have us name the file. So we'll call this test 3 units. And I'll put that on the desktop so I can find it. And save. So now it's saving and recording the data. So I'm going to zoom in on this a little bit so we can see the pressures we're doing. So I can do a shift, click and drag here, and we'll kind of get in the the pressure zone we're looking at. So you can see it's pretty calm here. You can see we're getting a little bit of envelope pressure, but it's pretty calm. So I'm going to click on start our baseline periods of record, and we'll call that our pre-base. And the default baseline period of record is 3 minutes. So this the baseline will run 3 minutes, and then fan on periods of record will each run 30 seconds. So those will go quicker. So as we look at our gauges here now, we've got our 3 gauges, and you'll notice each of those gauges has a slide bar. So each DG700 has a fan control cable input on it, that 3.5 millimeter audio cable that connects your DG700 to your fan speed controller, and each one of those has one of those ports. So each gauge has the ability to control one fan. If you use your master controller, then all of the gauges, every gauge is going to get the same amount of power to the fan, and it will just move the master controller across. But in this case, each of our units are going to be cruising a different flow and a different pressure. So we're not going to use the master. So I'm going to just go up to View, and we're going to show that not show the master controller, because we're going to be cruising each one of those at separate flows. We don't want them to all be the same flow. We want them to be the flow required to get the unit up to 50 pascals. So these are cruises for Unit 1, Unit 2, Unit 3 fans, and we can see we're set to depressurize 50 for our first data point. And I'm just going to do a quick 3-point test. So we're just going to do 50, 40, 30, and then we'll look at the results. And then we'll do another baseline after that. So what this is telling us is, so it's recording the average of those 3 pressures, because it's assuming you're doing a single zone test on a single building with multiple fans. So it's giving you the cue that you need to adjust your target for the baseline. So in this case, if we were doing a bigger building, we just adjust our baseline by 0.2 pascals. So I'm going to click OK here, and what we're going to do now is I'm going to click inside this baseline period of record, and that made that green outline white when I clicked in it, and then I'm going to right click in it and choose Show Stats. And what that's going to do is it's going to give me the pressures for Unit 1, 2, and 3. So if we look at envelope pressure, average, we're at about 0.2. .2 for Unit 1, and it's a negative. And it looks like we're about the same, 0.2 for envelope 2, and then envelope 3 we're at 0.1. So 0.2, 0.2, and 0.1. So not much wind today. It's really same temperature inside and outside, and not much fluctuation. So what I'm going to do here is I'm going to change, we want to induce the pressure by 50 pascals. So I'm going to go negative 50.2 here, negative 50.2 here, and negative 50.1 here. So we're going to change the pressure in each unit by 50 pascals. So that would be very similar if you were doing just a test on your gauge and you enter the baseline in there and then you're cruising 50. It's doing essentially the same thing, just using the software. So now I am going to uncap all of the fans. I'm going to just go down to mark all devices as open, and we've got all our fans uncapped now, so we're ready to test. And I'm going to click the cruise button. So now it's going to start cruising those, and I'm actually going to speed up the cruise. I'm going to speed that fan adjust rate up a little bit faster on each of those. This is a config button off to the side here, and that will just speed up our test a little bit by making the fans adjust a little bit quicker. So we've got open fans on all 3 of those duct blaster fans, and we can see our labels over here are envelope 1, envelope 2, envelope 3 in green, and then fan 1, fan 2, fan 3, and what rings they have and what the flow is there on 4. So let's see, I think I'm gonna do an auto Y here, so we can see that our fans are starting to, looks like our fans are starting to level off. So I'm going to click fan on period of record up here where my arrow is, fan on period of record, and we'll call that our negative 50 point. And that'll just go for 30 seconds. And then I'm going to click up, the up arrow twice. When I click on it, it goes 5 pascals at a time, and we're going to go from 50 to 40 for our next period of record. So we're getting pretty close. Yeah, we're getting, so now we're past that box, and this is the part that's going to be included in our data included in our test. So we're going towards 0, so I'm clicking the up arrow twice. So now we're going to cruise 40, induced pressure of 40 pascals on each. And our pressure's leveled off pretty quick. I'll wait till our fans calm down a little bit. They're kind of fighting each other to try to get 0 pressure between the units. And we'll go fan on period of record, and we'll call that negative. $40. So we can see the total flow from all 3 fans here, and then we can look at the flow from each unit as we're going through and what our pressures are. So I mean, it's great being able to see it on a graph and also see all the numbers as we're going along. So our next data point is 30, so click up. Some of the other things along the top, we've got a region select tool where we can move that and see pressures or flows. So now what's being shown over here is the pressures and flows at that data point. Okay, I'm going to click our third fan on period of record, and we'll call that negative 30. And then we have a region select tool, which is what will create a box like these boxes are, and we can choose to either include that in a period of record or not. So if we had some event going on, we could either make a period of record, or we could use an event marker. An event marker is just going to put a line there that you can label. So if a window popped open or something like that, you know, you can make event markers throughout the process also. Okay, so looks like we got our data. So now I'm going to turn the fan off. There's a little fan off button here. Turn the 3 fans off, and then we're going to cap those, and we want to mark them. We can go down here and mark all devices as sealed. So now all 3 of our fans are sealed. We're ready for our we're going to do a post baseline. Also, a lot of protocols like ASTM E779 or want you to do, or the ResNet test, they want you to do a baseline before and after the test. So we're going to do a post baseline. Drag that over. Okay. And then we can just auto T or auto Y our screen to move those things over. And after our baseline period of record, what I'm going to do is we're gonna, for diagnostic reasons, we're gonna do a total leakage test on each unit. So we'll do the test with 1 fan on unit 1 running first, and then units 2 and 3 are capped, and then we'll do a test on unit 2 with 1 and 3 capped, and a test on 3 with 1 and 3 capped. And when we look at that total flow of each of those units, and how pressures change in adjoining units as the fan goes on, we can kind of get an idea of where our leakage between the units is. And if we're trying to compartmentalize the units and have the biggest effect on our compartmentalization test, that'll help guide our air sealing that way to find out where the biggest leaks are between units. So we're going to run that information also. And when we're done with that, then we'll show you how to get the leakage from all three of these. So we're through our second baseline, and it's giving us a cue that, you know, before we end our test, we should check our results and see how our information looks. So I'm going to click up on the results button here, and we can see we've got all three data points are following a line pretty well, and we've got really good, because it's so calm, we've got really good correlation coefficients. We want those numbers to be around 0.99 or better. So that looks good. And our total leakage for all three units is listed here, and then our 95% confidence interval here. So what that's telling us is that our real results, if we look at the accuracy of this test, are somewhere between 3052 and 3251. So we're getting some pretty good data there. So click OK, and now we're gonna go open fan on unit number one, our fan number one, and then we're gonna bump that one up to cruise 50 pascals. Oops, going the wrong direction here. 50 pascals, and we'll start that fan. I'm gonna bump these up too. We're not gonna start those fans because those are capped, but I'm just gonna bump those up. So now this is showing us our total leakage of just unit one. I'm going to hit auto Y here so we can see, yeah, it looks like our fan is panned out there. So I'm going to click a fan on period of record, and we don't want to include this in our air tightness results because that will really throw us off. So we're going to unclick that, and we're going to call this total leakage for unit one. Okay, and I'll turn that off, and then we're going to cap that fan, so mark that one as sealed, and then unit 2 fan, we're going to go with open on unit 2, and then I'll cruise just number 2. And we can see our, you know, when we do that, our speed controller starts moving across here, and we see our pressure in unit 2 moving up, and then we can see the pressures in the adjoining units are moving up also. There's not a whole lot of connection between the units. We're seeing, you know, close to a pascal between units, and that's good information to have too. That gives you a sense of how interconnected those units are. You want them to be within 10%, so you'd want those to be within 5 pascals of each other, and we're only 1 pascal, so there's not a lot of leakage between the units. So it looks like both of our, you know, our pressure and our fan flow are leveling off real good there. So we'll call that total unit 2. Okay, we've got our 30 seconds of data for that, so we'll turn our fan off, the fan off button here, fan off, and then we're going to cap that one, mark it as sealed, and on the third one we're going to go open and cruise fan for the third one. Oops, I got to go up to 50 on that one. Oops. One thing I noticed, you see how this one has a different outline on it? That's because it's not included in the period of record. But this one I forgot to do that. We can see we've got a solid green line. So I'm going to click in that one and then right click and do edit period of record, and I'm going to unclick that. So we want to make sure that we're not including that information in the period of record, and that's what gives you that clue. A solid is fan on period of record. This bold outline is a baseline period of record, and these other ones are periods of record, but they're not included in the test results. Okay, so this one looks like our fan is cleaning off pretty good there, so we'll do our last unclick total unit 3. So we can see our, just based on our fan speed here, that unit 2 was tighter than unit 1, and unit 3 is leakier than both of them. You can just see that right off of the graph there. Okay, so now we're complete there. So I am going to turn our fan off. And I'm going to stop recording. And then it asks us if we want to load that file we just created, and we do. We want to look at our data now to do the analysis. So now, first, let's get the total leakage or unguarded numbers. Unit 1, I'm going to click in here. I'm going to do a right click to show stats. So this is showing me the stats for that period of record. And we can see envelope 1 was at 50.2, and we had a 0.2 baseline, so that looks really good. And our flow, our total flow, about 1296. So our unguarded unit 1, 1296. Okay, and then we'll look at unit 2. Show stats. Unit 2, we're pretty close. We're at, we want to be at 50.2, and we're at 50.1 in our total flow, about 1234. So that's our total leakage unguarded for number 2. And then click, and then right click. Show stats. 49.9. We wanted to be at 50.1, so we're pretty close there. We're at 1436. So that was the leakiest of the 3. Wrote that down. Okay, so now, when we go to our results, we're showing the total leakage for all 3 of those added together. But if we want the individual leakage, what we'll need to do is I'm going to use this region select tool up here, the second box over region select tools. When you hover over that, you can see that label comes up, region select tool. We're going to click on that, and we're just going to drag that across our whole multi-point test. And then once we do that, now we can, it's going to show we have multiple, because some periods have rings sealed, some periods we have rings unsealed. So we're gonna show open fan, because we're gonna look at unit number 1 first. So we're gonna show open fan for that, and then sealed for the other 2. And then go to our results. Now it's showing us our multi-point regression for just unit 1. And we can see our guarded test with all three fans going for test number 1. Oh, there's one other, before I do that, there is one other thing I want to do for our configuration settings. I'm going to want to, so unit 1, we want to keep our envelope pressure for unit 1 on, and I'm going to change unit 2 and unit 3 to pressure instead of envelope pressure. So it's not averaging all those 3 pressures. We're only looking for the pressure on unit number 1. And that's probably not going to change our results a lot because all those 3 were at pretty close to the same pressure. So we're at 1056. I'll write that down, 1056 for unit 1. Okay, and then we'll want to save this. We'll do a save data as, and we'll call this guarded unit 1. Okay, and now I'm going to load that our original guarded test here. And now we're going to do that same thing again. So this time for unit 2. So unit 2 will have open fan, the other 2 will leave as sealed. We'll go to configuration settings, view and edit channel settings. Unit 1, we want to change that to pressure because it's unit 2. Then I clicked on unit 3. We're on unit 3 now. We want that to be pressure. Unit 2, we want to be our envelope pressure. Okay. Okay. Test results. So we're at 971. Second one. And then we'll want to label that one. Save data file as, and we're going to call that guarded number 2. Number 2. Save. And then we're gonna load up our test here again. Choose our region select tool. Want that one sealed. We want that one sealed. We want unit 3 open. Configuration settings. View and edit channel settings. We're doing unit 3 now. So unit 1 pressure, unit 2 pressure, unit 3 envelope pressure. Okay. Okay. And go to our test results. And we're at 1125 for unit 3. So that's our multi-point results for our unit 3 test. And then we'll save that one. Call that guarded number 3. Okay, so now let's look at, let's enter those results in a spreadsheet, and we'll kind of have an idea of where we're at. So our unguarded was 1296, unit 2 1234, and then unit 3 1125. Oops, that's our guarded. 1051, 970, 971, guarded 1051, 971, 1125. And then our unguarded 1297, 1334, 1436. Okay, so we can see that that our total leakage changed by about 21%, and they all moved by about the same amount, which is unusual. Usually you'll see the middle unit move sometimes by twice as much as the outside units are, because there's more leakage between units that way. So that kind of gives you an idea. You know, you can easily get a 20% difference between doing a total leakage test with all the fans running and then a guarded without them running. So I'm just going to go back up to our PowerPoint, and we'll take some time now to answer questions. Thanks for attending our webinar, and as I mentioned before, please give us feedback on how you think this went, and also what webinars you'd like to see in the future. And now we'll review some of the questions you have.
All right, let's see. Yeah, you can go ahead and type in more questions as you think of them, but I'll go over about a dozen or so of the questions that came up during the session. One question was, what's the difference between floor area and surface area? You know, when you're figuring surface area, if you've got a simple cube, let's say, you'll take the floor area plus the ceiling area, square foot of the floor plus square foot of the ceiling, plus the square foot of the wall area. So you'll do length times height on each of the walls and calculate that to calculate the total surface area. Another question was, can the ResNet guide be used for retrofit buildings? And certainly it can. They did design that ResNet guide so it could be used for new construction or existing buildings, and they could be one-level buildings or mid-rise, or, you know, low-rise up to 3 stories, mid-rise 4 to 5, or high-rise taller than 5. So they kind of developed that guideline to be used for all types of multifamily buildings. Another question was, can you pressurize a building? And certainly any blower door test, you have the option of either pressurizing or depressurizing. Some standards like E779 require you to do both and then average the results. And the software will do that for you. And you can do a depressurization and a pressurization test on the same TechLog file. And the way you do that is, you saw I did a baseline before and after the test. If I did a second baseline in a row, if I do 2 baselines in a row, then it switches from test 1 to test 2. And it's assuming that you're starting a new test when you do 2 baselines right in a row like that. So one is a post-baseline for depressurization test. The next baseline is a pre-baseline for pressurization test, and then we're into test 2. So you can do both those tests on one file, and then it'll average those. Can you test 24 units, and what software would you use? You can with Techlog 3, the software that we're demonstrating there. There's room for up to 16 gauges. So, if you're testing townhome type buildings where you need an outdoor reference for each building, then you're limited to 16 units. But there are people that have done this test with 2 computers. So you have Techlog running on both computer, and you can have the computers right next to each other, and you just need to synchronize those periods of record. So you can add the flows, include all of that information. So you're depressurizing all the units and controlling them all from the software. If you're testing big buildings where you have 3 fan setups like that, you can control 2 fans from 1 gauge. So then you can test with a lot more fans. If you just had 1 outdoor reference and you had 16 gauges, you could have 17 fans. You could have a lot of additional fans that way. Let's see, which protocol would you use if indoor air quality is a concern? And for that one, you would use that first resonant protocol we talked about, where you're doing a compartmentalization test of a unit, and you're seeing equal pressures on all sides of the unit, and so it's looking at leakage to adjoining units and leakage to the outside, and they're all treated the same. And so if you make the tightness between the units tighter, it'll show up on that test. And it's certainly good practice you don't want to do a great job of air sealing all the exterior and leave all the interior spaces unsealed. For energy reasons, that makes a lot of sense, but for air quality reasons, it certainly doesn't. Because, whether it's tobacco smoke or cooking odors or other odors or other pollutants, they can travel from unit to unit, and you're all living in one big open dormitory building in that case. Let's see. When I was using Techlog, why did I choose a duct blaster configuration when I'm doing a blower door test? In this case, we were using duct blaster fans to do the blower door test. So we've got that red nylon panel with a hole in it the size of a duct blaster, and we were actually using a duct blaster as a blower door. It certainly, you can get up to 1350, 1400 CFM through a duct blaster fan in the open configuration, and even more than that. We've changed the blades on those a little bit, so you can get a little bit more than 1400 in some cases in doing that test. And there's certainly lighter fans to haul around if you have access to duct blaster fans. It's a good option for that kind of testing. The Techlog test, they noticed that the fans were at about negative 110 Pascal. So if you were watching that red line and you looked at the graph and what that correlated to, the fans are at about 1000 CFM, but they were showing negative 110 on the graph. And that's because that red line was fan pressure. Remember the DG700 and the software, the TechLog 3, is reading pressure at the flow sensor of the fan. And then so it's always on channel A and channel B, it's always reading pressure. That's what the gauge is seeing. But it's converting that pressure to flow based on which device you're using, blower or duct blaster, which ring configuration you had, open, ring A, etc. So it's converting that pressure to flow. So it was graphing. What I was displaying on that screen was building pressure and fan pressure. And the reason I did that was because it's easier to get 50 pascals and 110 pascals on the screen. If you had 50 pascals and 1,000 CFM on the screen, you could do it that way, but then it's really hard to see what pressure you're at because the scale is different. So that's why I was using fan pressure instead of fan flow to look at on the screen. Bill mentions, I can see I'm going to be watching this one again. And that's certainly true, especially when you're using software. You really don't get the hang of software going through it by just watching it. The only way to really get the hang of it is to try it out and get your hands on it and play around with it. Even if you're just using it with one fan, getting used to the software, the only way to do it is get your hands on it and play around with it. We do have a webinar series on TechLog too. If you're want to look more into using TechLog, we actually had a 4-part webinar series because there's a lot of things you can do with that software, and it's too much to cover in just one viewing. But it's great to go through that 4-part series where you watch part 1 and then you play around with it a little bit, because that's just showing you the real basics. Play around with a little bit before viewing the second series, and then that gets into a little more detail, and so on as you go through it. It goes through some basic multifamily testing, and then bigger building multifamily testing with a single zone. So that's certain. But these are great resources if you're if you're going through it and can review the webinar to see how different things were done. You can it's a good learning process. Stephanie is asking, is it possible to use the duct blaster fan and Model 3, Model 4 blower fans in parallel? And I'm assuming by that she means can use them at the same time on the same test. And that's certainly true. Model 4 you won't see because that's a different fan. That's a European fan. But you could use a combination of duct blaster fans and blower fans, certainly, during a test. And you can use a combination of Wi-Fi links and cabling to connect gauges to your computer. You can take all of those things into consideration. David is wondering about how you deal with elevator shafts, and would you seal it off or use it as sealed or unsealed as a reference? It kind of depends. Typically, the protocol you're following will give you guidance on what you can seal and what you can't seal during a test. And usually, some are more specific than others. The Army Corps standard is pretty good. There's another, ABA, the Air Barrier Association, is coming out with a standard too that's going to go into even further detail on how to set up that's more commercial buildings, but it would apply to multifamily also on what mechanical openings, for example, you would seal on a building. Even multifamily buildings have ventilation systems that will, oftentimes pressurize a hallway, and they have large openings that bring in outdoor air, and sometimes they have dampers, sometimes they don't, and so they're huge holes that sometimes are as large as a door, or maybe even as large as a garage door opening, depending on the size of the building. And a lot of times you need to seal those off, or exhaust fan terminations on a roof from rooftop units, or kitchen fan openings, or large undampered openings that need to be sealed. So there'll be different standards on what you're allowed to seal and not seal. But generally speaking, we're involved with testing an 11-unit dormitory building, and we set up all the fans on one level, on the main level, and monitored pressures with the top floor with reference to the floor we had the fan set up on, and they were less than 5% different between the 11th floor and the floor that on the main level that the fans are set up on. So there's 3 stairwells where you could prop open all the doors and even out the pressures between units. So you can test, if you have a lot of stair openings, or I don't know if you'd want to prop open elevator doors. That could get dangerous, but elevator shafts are certainly a problem with, it'll help you interconnect the building, but leakage through elevator shafts are certainly an issue as it gets to high-rise buildings. Scott is asking, and this is a question we do get a lot, is how can you ensure that you get BPI CEUs for the class? You won't be getting a certificate or any kind of notification that your BPI CEUs have gone through, but you'll have to check the BPI site where you check to see what the status of your CEUs are. And I would say if nothing has appeared in 30 days, then definitely give us a call. But they've been pretty good about all of the people who were registered for the class will get. And in this case, I mentioned at the beginning it was 1 CEU, but this is a 2-hour session, so you will get 2 continuing ed credits if you stay through the whole thing. So if you logged on using that email address, then you'll get credit. Okay, we've got a few more questions coming in here. Tim would like to get his hands on the ResNet guidelines for multifamily radio. You'll find it, and if you don't, Norbert was asking, does TEC offer hands-on testing? And we have done that a few times with Terry, and we also just last month at Face down in Atlanta. And I'm kind of hoping that South Face will run another one. That one went really well down there, and they've got the Sweet Center is a great training facility down there, and it worked out really well for multifan testing. And it was a 2.5-day class, and and a good half day of it was just hands-on setting it up and running the software. So we may do that again. Keep after us if you don't hear about one being scheduled, and we'll try to get something going. Oh, it looks like Tim did find the copy of it online. The email address to send CEUs, either just go on our website and send it to our just generic address there, or you can send it to Kim K. Tanner, TANNER, if you can get her your CEUs, we'll make sure you get credit. Well, that about wraps it up. I think we've covered all the questions. Again, feel free to let us know what kind of webinars you'd like to see in the future. We're always looking for ideas, and thanks for attending.